Greetings and welcome to a lecture on header files. So, a little bit of sort of background understanding on this one first. In C++, and in fact in most languages for that matter, it's phenomenally rare to have single file solutions to anything but the simplest of problems. You certainly do have single file solutions, but they are quite rare. You typically don't do this. Especially in the case of C++, where we have to have something defined before we can use it. Like we saw last week, if we tried to use the function in main before the function was defined, we got an error. We were not allowed to do that. And so we had to do the function declarations above main, and then we did our function definitions after. But part of the idea behind functions is you might want to reuse these in other places. I might not, I might have multiple files, and multiple files might want to use the same function. I definitely do not want to write the same function multiple times in multiple files. That is a horrible idea and will lead to massive bugs and defects in your programs. I would want to write the function once and then use it across multiple files. Same thing for classes once we get to that. I don't want to have to define a class in every single file that's going to use it. I want to define the class once and then bring that definition into whatever file happens to need to use it. And so that is where in C++ we get into this concept of a header file, which is just simply bringing in the definitions, or the declarations, I should say, and the source files, which actually have the definitions. So let's take a look at this. Make sure, of course, that you are in the lecture project. Don't be accidentally creating things in the header files project. In fact, I'm going to collapse that down. So again, make sure that you are in lecture. And I am going to go to header file, and you need to as well. And we're going to right click, add new item. And we are going to call this demo a.cpp, or it's not .cpp, .h, because this is the header file. Again, demo a.h. And then click on add. And if you've done this correctly, you should see this line in your file, pound pragma once. We'll come back to that. Now, over here in source files, we're going to want to create the corresponding CPP file for this. So we are going to right-click, and make sure you are on source files, right-click, add, new item, and again, we shall call this demo A, and this time we do want .cpp. Now, a header file and its corresponding .cpp file do not actually have to match. Syntactically speaking, having these two files match is not required. However, for purposes of this class, it is required. Your .h file and your .cpp file must have the same name. The vast majority of C++ programs will do this. Any sensible workplace will enforce this kind of ruling. So even though it is syntactically not required, your CPP file and your .h file, the file name itself must match other than the extension, obviously. Now going back to the .h file, we're going to continue to ignore pragma once. We're going to put in our function declarations. Remember, the function declaration is just simply the one line that shows off the function signature. And for this example, we're going to do void, say, hello, and that is it. Void say hello. That is our function that we are declaring here. Now that we've done that, and we will get some squiggles here warning us that the IDE cannot find a definition for this. So we've declared it, but it can't find a definition. So let's get that definition in. Let's come over here to demo.a.cpp. Now the first thing that we are going to want to put in here is an include for our .h. Not needed in this highly simplistic example, but if we had functions calling each other, it would be mandatory. So we do need to put in an include statement here. Now, when we do include IOStream, we use the angle brackets. When we're including our own personal .h files, we use the quotation marks to help indicate that, hey, this is our .h file, not part of the libraries. And we're going to put in include demoa.h. Since I'm going to be using cout here, I also need to include IOStream. So I'm going to put in an include angle bracket IOStream. Now I need to actually define my function. So we're going to say void, say hello, and it's just going to be cout hello. So, and if you want to, by the way, if you are going to be using namespace standard, you can of course put in the pound using namespace std up here if you want. Oops, without the pound sign. So you can put the using namespace std up here if you want, but as per usual, I will not be doing that. So std cout hello. And that's it. That's all we're going to do. And now if we go back over to our .h file, the green squiggles disappear because now the system's like, the IDE is like, oh, hey, yeah, I found a definition for that. Now we still can't use it. If we come over here to lecture.cpp and we try to say hello without any unfortunate typos, yeah, no, we get red squiggles of doom because it's like, yeah, no, I have no idea what you are talking about. If I mouse over this, it will say that say hello is undefined because I haven't told lecture.cpp to look for that .h file yet. So I'm going to put in include demoa.h. Notice that here I've got include demoa.h, then IOStream. In lecture, I have IOStream, then demoa.h. 6 of one, half dozen of another. It doesn't matter. The order in which you do your includes is largely irrelevant. And now if we run the program, so I'm going to hit F5. It builds, and there we go. Hello is displayed to the console. All right, let's backtrack for a moment and take a look at this pragma once. And to help understand that, let's look at lecture.cpp and demoa.cpp. Oh, and by the way, in case you missed what I just did there, if you left-click drag on these tabs, you can detach the window. And I am putting my mouse cursor over that little window icon there, so that way I can have the files open side by side. And I want demoa.cpp open and on this side. Again, you do not need to arrange your files like this. I'm just arranging my files like this so that we can see both files simultaneously. So lecture.cpp includes IOStream. Demoa.cpp includes IOStream. I am including the same file twice. This could lead to problems because it's going to go through and try to do all the declarations that IOStream has. But if it's already been declared, you'll get a name clash, identifier already in use. So what this pragma wants, this is called a compiler directive. Anytime you see the # and then something like this, # pragma, # ifndef, #def, so on and so forth. These are called compiler directives. These are instructions to the compiler to do something specific when it's processing the file. And pragma once is sort of a shorthand way of saying, hey, compiler, only process this file once. If you have already seen this file, don't process it again. And this is very important to include in your .h files because you never want a .h file to be processed more than once. It can lead to very strange errors if not your program just flat out not compiling. So Visual Studio will automatically put this line in for any .h file that you create, but just make sure that it's there. You always want a pragma once compiler directive as the first line in any .h file. Because as we can see here, both of these files are using IOStream, which does have that pragma once in there, because if it didn't, this would cause a problem. Go ahead and close that out so I'm back to a single file. And let's expand upon this a little bit, because you can have, .h files that include other .h files, or it's perfectly reasonable. So what if we wanted to say hello there? Well, just to practice, let's do this in a separate file. So under header files, I'm going to right-click, add new item, and I'm going to call this demob.h, because again, this is the header file. So demob.h, click on add. Down here in source files, right-click, add new item, demob.cpp. For my function, I am going to declare void say hello there, and that'll be it. So we're done with our demob.h. Over here in demob.cpp, I'm going to include 3 files. I'm going to include IOStream because I need cout. I am going to include demob.h because obviously. And I'm also going to include demoa.h. So we got our 3 includes, IOStream, demob, demoa. Now we're going to define our function. So I'm going to say void say hello there. And we're going to do std cout y space. Don't do an indel. Say hello. And then std cout there. Why, hello there. I'm going to come back over to lecture.cpp and I'm going to include demob.h .h, which again also helps demonstrate why do we need that pragma once, because demo B is going to include demo A, but I've already included demo A right here. I don't want to process that file twice. So very important that we have the pragma once in there. Now, if you decide to get clever and see what happens when you take the pragma once out, your efforts will be foiled by Visual Studio itself, which the linker is intelligent enough to figure it out with such a simplistic project that, oh, I shouldn't process this file twice. But in more complex project scenarios, or say when you're trying to like include files across projects, which is possible, it will cause problems. So no, you cannot force an error. This project is too simple, but you do need the pragma once in your .h's because it could cause issues. I'm going to do a indel here. So that way we have a line separating things, and then we'll say, hello there. Run it. And there we go. Why, hello there. Of course, the hello is capitalized, but yeah, what can you do? And that is how you use header files, or at least the basics behind them. So again, to review, a header file will contain the function declaration. This is declaring a function. Naming's important. Then, in the CPP file, which syntactically the names do not have to match, but as far as this course is concerned, the names must match. We will include the .h file, so include demoa.h, and then we define the function. This is a function definition. It's very important that you keep these terminologies straight. Function declaration, declaring a function. Function definition, defining a function. And when you include your own .h files, you use the quotation marks instead of the angle brackets. And a .h file should always start with the pragma once compiler directive. Okay, let's take a look at the assignment before we wrap things up. So for the assignment, you will need to create two files, helper.h and helper.cpp. Inside these files, you are going to declare and define is left bigger and is right bigger. Each function will take two parameters, left and right. Left is always the first parameter, right is always the second parameter. Is left bigger will print true if left is greater than right, and false if left is less than or equal to right, and the obvious inverse for right is right bigger. Before I continue to go over the rest of the assignment, just hop down here. Hopefully it's pretty self-evident what's going on here, right? Is left bigger? This is the left-hand side. This is the right-hand side. So this would return false because the left-hand number is not larger than the right-hand number. You will need to create all needed overloads to the function below or run. You are not allowed to modify this. You are not allowed to change anything inside of int main. And this code needs to run. Now, obviously, if you try to run it as is, you're going to get build errors. It can't run. These functions are not defined. So all of the you are not allowed to this here. Sorry. Make sure I am not skipping steps here. So create all needed overloads. So all of this has to run. You are not allowed to define or declare any functions in main.cpp. Strictly forbidden. Pretty much you are not allowed to modify main other than putting in your include statement. But you're not allowed to modify the main method, the main function itself, and you are not allowed to put in any function definitions or function declarations inside main.cpp. All function definitions need to be in helper.cpp. All function declarations need to be in helper.h. And when you have everything set up correctly, this is what your output should be. As always, if you have any questions, make sure you post a message on Blackboard checking in with your instructor. And that concludes our look at header files. Good luck with the assignment, and I'll catch you on the next video.